Mr. Actor, and thank you very much to the person who sent in this question. Well, the question that was sent in is this question on the left, where you need to find the value of n. And so what I'm going to do is I'm going to work through this question on the left, and then I'm going to give you some time to work through the question on the right, which is similar, and then you can compare your solution with mine. So let's start off by looking at the question on the left. Okay, so here's the first question. And I'm going to start by writing everything in base 2. What do I mean by base 2? Well, I mean I'm going to write everything as 2 to the power of something. So the square root of 2 is 2 to the power of a half. And that's being divided by, now on the top of this fraction, I've got 8 to the power of 3. And 8 is 2 cubed. So I'm going to write this as 2 cubed to the power of 3, rather than 8 to the power of 3. Now, on the denominator there, I've got 16. Now, 16, what is that? 16 is 2 to the power of 4, isn't it? So that is 2 to the power of 4 to the power of 3 halves. And that equals 2 to the n. Okay, right. I'm going to continue to simplify my left-hand side, continue to be working in base 2. So I've got 2 to the power of a half. Now, the numerator of that fraction, 2 to the power of 3 cubed, is, according to my rule of indices, 2 to the power of 3 times 3, 2 to the power of 9. And that's being divided by, now, 2 to the power of 4 to the power of 3 over 2. Well, that's 2 to the power of 4 times 3 over 2, which is 2 to the power of 6. Because 4 times 3 halves is 6. So I've got 2 to the power of 6 here. So that is going to be 2 to the power of a half divided by 2 to the power of 9 divided by 2 to the power of 6. We'll subtract the indices if you divide. So that's 2 to the power of 3, or 2 cubed. And now I've got 2 to the power of a half divided by 2 cubed. If I subtract those indices, I end up with 2 to the power of minus 2.5, or 2 to the power of minus 5 over 2. And that is the first of those done. Now's your chance to have a look at a question that's similar. Okay, so here's a similar question, perhaps a bit more complicated. And what I would do is I would write each of those elements on the left in base 2 or in base 5, or in a combination of both. And I would take it from there. Have a go, and then press play, and watch me work my way through it and compare our solutions. Right. Pause the film now and have a go. Right, so let's have a look at the left-hand side here. We've got 10 to the power of 4n. So that is 2 times 5 to the power of 4n. And then we're multiplying that by 2 to the power of 3n squared minus 15n. And we're multiplying that by 5 to the power of 2 minus 4n. And that is all being divided by 20. What's 20? 2 times 2 times 5 squared. And we know that that equals 1. All right. So 2 times 5 to the power of 4n is going to be 2 to the power of 4n times 5 to the power of 4n. And then I'm multiplying by 2 to the power of 3n squared minus 15n times 5 to the power of 2 minus 4n. And that's all divided by, let's have a look, 2 squared times 2 squared times 5 squared. Okay, let's simplify the top here. Let's do my powers of 2. I've got 2 to the power of 4n times 2 to the power of that. So I'm simply going to add the indices, add the powers. So I'm going to get 2 to the power of 3n squared plus 4n minus 15n. Okay, well that is 2 to the power of 3n squared minus 11n. And I've also got 5 to the power of, I've got 4n plus 2 minus 4n. So that's just 5 squared. All over 2 to the power of 4 times 5 squared, and that equals 1, of course. Now can I not divide top and bottom by 5 squared? Yes, I can. So what I've got now is I've got 2 to the power of 3n squared minus 11n divided by 2 to the power of 4, and that equals 1. Okay, well, if I'm going to divide those powers, divide the expressions on the left, then I'm going to subtract the powers. So I'm going to have 2 to the power of 3n squared minus 11n minus 4, and that equals 1. Now, what is 1 to the power in base 2? Well, 1 is 2 to the power of 0, isn't it? So I've actually got 3n squared minus 11n minus 4 equals 0. 3n squared minus 11n minus 4 equals 0. So I can solve this quadratic equation to find values of n which will satisfy the equation. I'm going to try factorizing first. I know it's 3n squared, so it's got to be 3n and n. Now I've got, they multiply to a negative, so I'm going to have a plus and a minus. It's either going to be a plus and a minus or a minus and a plus, isn't it? And I multiply to 4. Right, so this is going to need some trial and error, I think. 4 could be 4 times 1, couldn't it? So if I put my 4 here and I make that minus, then that's going to give me minus 12n. So I'd need to have a plus 1 here to give me plus 1n to give me minus 11n, and that multiplied by that does give me minus 4. So I factorized it correctly. That's good. And now I can write down my two values of n. N will be minus a third or 4. There you are. Well, that was more tricky than the first example. I wonder how you got on. If you'd like a hand with your indices, you'd like to do some more practice, I will put a link to a film which contains some more IGCSE and indices questions for you to practice. If you'd like a hand, leave me a question in the comments, and of course I'll respond. And if you'd like me to solve a question that you're stumped on, email it to me. My email address is in the description of this film, and then I'll have a go. Thanks for watching. See you in the next film.